There's another button I had to click. Okay.
Go ahead,
This
Bruce.
is the SRC student presentations. Take it away.
All right. So I'd like to introduce Pedro Castaneda. He's been working with John and myself the past 6 weeks. The work we've been doing is more technological than scientific, but it's technology that scientists will use. We've actually been working with Pedro on building a Python application that will allow astronomers to create mosaic images of parts of the sky. And he is going to tell us all about how he managed to do that.
Okay. Should I share my screen with my presentation?
Yes.
Yes.
Can you enable it? Or the hostess?
You have to
Done.
let him do it.
There we go. Yeah. Okay, so hi, my name is Pedro Castaneda, and this is building mosaics with Sky. Building mosaics of the sky with Python, with assistance from Bruce and John. So why do we want to make a mosaic, what is a mosaic? A mosaic is like an image that is a collection of multiple images of a certain region in space. These pictures are taken with infrared cameras because sometimes there are stars or galaxies that are just too distant for us to be able to see. So we use these infrared cameras to be able to detect like the heat from these stars and distant galaxies. And so we use infrared imagery, and we compile a lot of these images together to create these large mosaics like the one that you see on screen. So I created an application that you can run on your Apple or Linux desktop, and it's going to be freely available to astronomers to use to create other mosaics from different regions of space. And the time to create these mosaics can vary depending on the size and data set that you're trying to use. Sometimes it can take just a couple minutes. The shortest I've seen for me was 2 minutes. And then the longest it's taken me was probably like 3 hours. You know, it varies. The larger the image, the more time it'll take. And depending on the data set you use will also affect how much time it'll take for you to develop the image. So why do we want to build them? We want to build these mosaics because astronomers need to study the structures of some of these like images that in space. And some of these structures are too large for you to just see through a telescope or through just a single image. So we developed these larger images with a collection of multiple images that are just taken, spread out, but collaborated together to create one larger one. And then they can study and the physics behind these structures, and also molecular clouds and the clusters of galaxies. So you would think that it's an easy task, right? Just put the images together. Well, it's not that easy because each individual image can have some sort of defect that can ruin the image or make the research inaccurate. Sometimes the defects can be that there could be a lot of cloud dust in certain areas that cover certain stars that you're trying to see. Sometimes the pixels are not always aligned, or the background from airglow is highly variable, which can affect to the images. And so this is why we created the montage image mosaic engine. And for example, on the right side, you can see these images. The three gray ones are different images shot with different wavelengths. And together you compile them together and refine the best images at the bottom right. The bottom right image is refined and it has no defects because we filtered all those out using this engine. So how it works is we created a class on the left called parameters, and inside of it we create an empty dictionary, and inside that dictionary we'll put in all of the parameters from a different file that have everything that we need to build the mosaic. It can have stuff like the size, location, kind of coordinate system you want. It'll go through that list and pull out every parameter that we need and until we need to build it later on. And on the right side, you can see another class that I made called Mosaic. Inside of this class is where we finally put the logic together to build the mosaic. We take all the parameters from earlier and start putting it into creating it. We create a work directory and a data set, and this is where all the information is going to be held. Inside the directory, we'll have two subdirectories that have separate files to hold the mosaic fits files. And a fits file is a flexible image transport system, and this is what we use to create these mosaic images. We use this because it preserves accuracy, scalability, and flexibility. So it's very useful, and also it can work on multiple coding languages, and it's just easy to use. So then as we go down the list, it also creates like raw, projected, this, and corrected directories. And here is just like thousands and thousands of lines of code that just hold all the information to developing these mosaics. And then once we run through all of this, we get our finished product. On the left here, we have Messier 51, and it's a galaxy, and all the white specks are also stars or distant stars in the background. On the right, we have Messier 17. That I believe is also a galaxy with a lot of stars. These images are very different in the sense that the coordinate system that I used were different. On the one on the right, I used the coordinate system called equatorial, and on the right, it's galactic. Uh, it's kind of complicated to explain the coordinate systems, but that's just what the lines and the times mean. And then this next one, both of these images are of the same one. They're both the galactic center, which is like 0.00 in space. The image on the left is just a more zoomed in version, and then the one on the right is zoomed out. There's not a lot happening, but I think it's probably one of my favorite pictures that I was able to develop. And using this code, astronomers can start developing their own mosaics, and they could research the structures of them, and I hope it becomes very useful to them. Thank you.
Great, thank you, Pedro.
Thanks, Pedro. So I think that now we have time for questions. And I think any of us can ask questions.
Mhm.
So I guess I will ask you one, Pedro, which is this new application now ready to be used by astronomers like me, or is it going to require a little more work? 6 weeks is not a lot of time. So just curious, what do you think are the next steps for bringing it to fruition if it's not already?
I think the next step for bringing it to fruition, well, this is out of my hands, but the next thing that needs to be done is that it needs to be packaged up into, I forgot what it was called, but it needs to be packaged so that it can be sent out to astronomers and they can easily access it and download it. There might be a little bit more refining to it because in the 6 weeks that I was working on it, I couldn't make it as specific to creating mosaics as possible. It was there was like a lot of gray area where it was general so that we could create like mosaics. But if we want more specific images or like more detailed ones, we might need to add like a little bit more parameters and such to, get like a better version of what I have. So what I have is like a general form that works and is functional. But if we want like better mosaics, there's a little bit more refining to do.
Yeah, that is generally the state of things, I find. Sydney, do you have any questions for Pedro or comments or something
I
you
was gonna
learned? Or...
say that was really cool, and all those pictures were you created throughout the program.
Mhm.
Oh, okay, that's cool.
Okay, do John or Bruce have questions? I mean, I know you've been
Well, I
working
could,
with him, so.
we could maybe expand on your question to Pedro a little bit. We need to make it accessible through PyPy so everyone can use it. There's some cleanup that we need to do, and we need to make some documentation for it, which would have been too much to be able to do in 6 weeks. But I actually think it's very close to being useful for professional astronomers, even as it is right now. There are many places we can take this in the future, and it was built to be highly extensible. Now we can add in, people can go and get their favorite catalogs and overlay them and things like that, all of which we can add in. Since the source code will be available, people can also edit the application themselves and do custom versions of it for their own use.
I have a question that may not be just for Pedro, just because I'm kind of curious about this, because it could be something that I could use. What is the difference between this application and existing? I thought Montage was available through Python. I thought I remember you giving a talk
Yeah,
about that.
it is. This is, you have to know how to put all the pieces together. And for a lot of people, all you really need on this area, just do it for me. That's what this does.
Got it. So
You would have to run like about 8 steps yourself. This runs all of them for you.
got it.
Yeah, I mean, John and I wanted to do this for a long time, but we've never had we honestly never had the time to be able to do it. So it was great that Pedro came along for the summer and took on the job.
Yes, I hear you. I hear you on the
One little comment, Pedro didn't cover. Some of those images are mosaics of literally hundreds of input images. So you think about like the image behind me, you know, the individual images are like this big.
Your hand is disappearing. I think you have to put it in front of your face or something because of the background. There you go.
Individual images are the size of my nose, which you know, is quite impressive.
Yeah. So maybe we can use this to make really cool Zoom backgrounds too.
Oh yeah.
Mm-hmm. Yes.
Gotta get our priorities straight, right?
Of course.
Okay, so if there are no more questions, then I think that we can have our second presentation by Sydney Brumfield, who is a student at Pasadena High School. Maybe Pedro was too, I wasn't sure.
I am.
Okay. Okay, Sydney, would you like to share your screen and your presentation?
Yes. Okay. Hi, everyone. I'm Sydney Brumfield from Pasadena High School, and today we're going to talk about galaxies, and more specifically in the field, filaments, and clusters. How are stars formed in the galaxy? Well, we measure the gas in galaxies by H1, which represents neutral atomic hydrogen. Galaxies are shaped in different ways, like shown in this picture to the right, and the most common forms are an elliptical and a spiral shape. The two other pictures you see are where I will be getting my information from in plots later in the presentation, so the Arecibo Observatory and the SDSS telescope. Galaxies are sometimes live in things called clusters, and you can say a cluster as a city of galaxies that are gravitationally bound to each other. In the picture, what you are seeing is the Virgo cluster. In the picture, what you can see are stars, but what you can't see is the gas that the stars are made of and that which new stars will form out of. What's different about galaxies and clusters? They have less star formation and they are different shapes and masses. When you measure the colors of galaxies and how bright they are, you can see that the galaxies begin to clump together, such as in the plot on the right. There are three different areas on the plot: red sequence, green valley, and blue cloud. In the red sequence galaxies, they are really red galaxies and have a large range of luminosities. The blue cloud galaxies are blue and have lower luminosities. And we call it the green valley because they are in the middle, and it's a valley because there's not many of them. All of these galaxies exist in a range of things from filaments, clusters, and in the field. But red sequence galaxies tend to have a higher ratio of galaxies in clusters, and blue cloud galaxies tend to have a higher ratio of galaxies that are in the field. Clusters have less star formation because they are in red sequence galaxies, and because they have less star formation, they end up red. And in this picture, you can see that the blue one is more of a spiral shape and the red ones are elliptical galaxies. What's around the Virgo cluster? The Virgo cluster has many things around it, such as groups, filaments, and voids. In this plot, you can see that little blue circle is the Virgo cluster. Each red star represents a filament, which is a string of galaxies. The gray dots are galaxies that aren't in filaments, meaning that they're either in groups or voids. Voids are where there aren't many galaxies, so you could say that voids are more towards the outskirt of the grass where there is a lot of white space. The groups are where the gray dots look more black because they are galaxies that are really clustered and close together. Now here in this slide, we see a pair plot. We use pair plots to compare each variable to each other. And in this one, we have three variables: log mass, log SSFR, which stands for specific star formation rate, and log MH, which is the gas mass. In this plot, we are comparing the field. And you can see in the diagonal, they are histograms and not plots, because instead of plotting each variable to each other, you make the histogram of it. And I'm just going to present to you some conclusions that we can make from this plot. So in the first red box, we can conclude that high mass galaxies have lower star formation rate in the field because of those dots right there. And in the second red box, we can conclude that low gas galaxies are outliers. This pair plot is showing a pair plot of clusters. In the first big red box, the histogram of mass, clusters have more high mass galaxies than in the filament or field because there are more peaks in this graph, meaning that there is a larger masses. And in the second red box, we can see that high mass galaxies in the clusters have wide range of gas masses. And in this last pair plot, we see filaments. Filaments have interesting outliers. In all three red boxes, you can see about the same amount of galaxies, and they're a lot different from the majority of the other ones. So we have all these pair plots, but what can we do after we make conclusions? Well, we can investigate how low gas galaxies in the filament and field, and also look at high gas galaxies with low star formation rate to see why they are so different from the majority. We can also make sure that the measurements are right and that our outliers are real. And lastly, we can see how the morphologies of the galaxies relate to anything else and how they may affect the galaxies. So the learning outcomes. Before this program started, we had learning outcomes and what we would like to get out of the program. Exposure to Caltech. Well, because of COVID, we didn't really get that much exposure to Caltech, but it was still very fun. But I did learn lots of concepts and practices of research because we mostly took data from tables and made them into graphs and posed questions. I also learned a little more Python than I already knew, so that was really fun. And I did gain confidence in believing that anyone can be a scientist if you work hard, because I didn't know anything about galaxies before I came into this, and now I can make a whole slide presentation out of it.
All right, thank you, Sydney. So now it is time for questions for Sydney. That was a really nice talk. Thank you.
I have a question. Oh, you first. Go ahead, Bruce.
Yeah, I was maybe more a question for Vandana than Sydney. Are you planning to make this a peer-reviewed publication, professional standard publication?
Yep. So this is actually research that we have in progress, and I have had this long-standing research group with people all over the country and also in Europe, and I have just had no time to dig into it myself. So I was kind of using Sydney to help me participate in this project, just to even explore the data. So we've taken a so what Sydney used was Sloan data and alfalfa data, but we've also taken a bunch of H alpha images and CO images. But I wanted to get like the baseline familiarity done. So yes, it's probably going to be many publications, none of which I will be leading, but yes, this will, I think, the kinds of things that she plotted will be in a publication.
Okay.
So in those plots, was it one galaxy per dot, or was it group statistics of some sort?
It was one galaxy per dot, if I'm not mistaken.
And did you trace any time where where the same galaxy was in different plots?
Oh no.
Just to see whether it's an outlier here, it's also an outlier there, it's also an outlier there.
Oh no, I didn't compare the plots.
We did talk about how they were likely the same. The outliers were the same in the various plots because you can sort of see the structure. Like, Sydney, remember those two prongs that were coming out, but they were in different directions.
So you took the ones that were in your boxes and colored them, red in the other plots. Where would they be? Okay.
Yeah. We just didn't get to that yet.
Never enough time.
Never enough time.
I have a question. So the outliers, like, what do they represent? Are they just like they didn't fit into the normal category for like their average or what they're supposed to be, or like what are they?
Well, I'm not sure if there's a specific number, but they're just in the plots. You can see that there's a big clump of dots, and those are just far away from them, so they're different. That's why they're outliers, and we just want to see why they're different from the other ones if they're living in the same environment.
Okay, thank you.
Yeah, I personally was most interested by those outliers that had, I think it was the second bullet in your conclusion slide, the ones that are full of gas, but for some reason are not forming stars. Just why didn't stars form out of that gas?
I have a question for both Sydney and Pedro. And these are very nicely organized presentations, which are very easy to follow. So have both of you had training in creating presentations at high school?
I wouldn't say training. I would just say that I just had quite a few projects that I've had to present in the past, and I just got kind of used to the system, how it works, and the expectations for what I should have in a presentation, and how I should speak or how I should dress. And it just become like a norm that I just developed through my years. And now senior year, it's just easy for me.
Mm-hmm.
Yeah, I would say the same as Pedro, not necessarily training, but I do remember in middle school I did a lot of speeches, so that probably helped a lot. And then you just do them over time and it gets easier.
Mm-hmm.
Do you two know each other, by the way?
We've met before at a summer camp.
Yeah.
Oh, cool. Well, because you're in the same high school, so I figured you might know each other. And are you, I know Sydney's in the App Academy at Pasadena High School. Are you also in that, Pedro?
Yeah.
Okay. I wasn't so sure how this cohort was formed in the SRC program. So that's interesting. Do you feel, I think we were supposed to talk about something that you learned from the other person's presentation. Is there anything that you weren't familiar with prior to these presentations that you learned from them?
I did know about the different types of galaxies and how there's the red and the blue field ones. and how they're very different, and not only like the way that they're structured, but just also like the material, like the gas that it contains. I thought that was really interesting.
I thought it was really interesting of how much work it took to really just get pictures from the sky and put them together for other people to get the, because you usually see people who get the research, but you don't see the people who are making the pictures so that people can get the research.
Wow, music to John and Bruce's ears.
That's right.
That's very true.
Yes, it is.
Is there anything else that people want to discuss today?
Let me ask a loaded question of both Sydney and Pedro. I mean, did you both enjoy participating in this program? Did you feel that you learned a lot from it?
I really enjoyed being a part of this program. I feel like I learned a lot, and not only was this like a learning experience, but it also just kind of opened my eyes, because for years I've always wanted to do like engineering in college, but I never knew exactly what I wanted to do. And then I was interested in coding, but I had no idea what applications coding had like in other jobs other than just making websites. And through this internship, I learned that coding can literally help so much in like fields of astronomy, which is just fascinating to me. You know, so this probably opened a possibility for me for what I want to do in college. You know?
What year are you in high school, Pedro?
I'm entering my senior year.
Okay. And that's the same as Sydney, right, Sydney? Yeah.
How
All right.
much did this the mode of interaction slow you down, you think? You know, if you actually could be with us in person, how much more do you think you could get done? Or less?
I probably could have gotten more work done, because sometimes I could have just asked like an instantaneous question, like simple ones or complicated ones that you guys could have just answered in the moment, which could have helped me progress further along. Because like while we did this for the past 6 weeks, I would have to send you guys an email and then wait for a response. And then since I didn't know your schedules or when you had meetings or not usually, so it would take some time before I'd get a response from you guys. So, you know, if we had like in-person communication, I feel like I probably could have had more work done. Probably some documentation for you guys.
Although our meetings would have still existed, so you would have probably knocked on our doors and maybe we wouldn't be available. But we would get to bug you guys more.
Yeah.
Yes,
Keep
it
in mind
works
that.
both ways. You know, I think it was a learning experience for all of us too, to figure out how to work efficiently with you students, because we've never done this remotely before. And so I think all of us were sort of thrown into a pot and trying to figure out how to best make it work. And I think the two presentations here, we did manage to make it work.
Sydney, did you want to address the question of what, I mean, you sort of had a slide on what you got out of it, so I guess maybe there's not that much more to say.
Well, I think it was a really good program, and I definitely learned a lot, because I knew a little bit of Python from my last year in App Academy, but I didn't learn as much of graphing plots and how it had to do with space, so that was really cool. And I learned a lot about galaxies while at it. And even though it wasn't in person, I still think I got a lot out of it, and it was really fun.
And Pedro got to do it from Oregon. Realize spent the whole time in Oregon.
You're in Oregon?
Yeah, I did the whole.
Oh, you're in
interview
Oregon. I
process
was like, who's in Oregon?
Yeah. Well, at least it's in the same time zone.
Yeah.
So I have a question for you guys. In Pedro's group, how often were you guys meeting online?
We tried to have a tag up every day at 4 o'clock.
Oh, wow.
And
That's more than we did.
And we had other occasional tag ups too, but we tried to make a point of meeting every day. At least one of John and myself would try and meet with Pedro.
And did you meet for an hour every day?
Sometimes it was an hour, sometimes longer than that. Sometimes it was just hang up and it would take 10 minutes or so. It did vary a lot.
Well, kudos to you guys because Sydney and I only met twice a week for an hour each.
Oh,
So she really did this
Yeah,
with a
yeah,
lot.
you shortchanged her. You really did.
yeah.
What?
You shortchanged her.
I thought
You
that was a lot.
slacker.
And there's only one of me. So if there had been two of me, then we would have been up to 4 days a week. I'm sorry, Sydney.
Well, I have to say it was made much easier because both John and myself were working with Pedro. If it had been just me, I would not have had the time to meet 5 days a week, and neither would John. And between the two of us, we were able to make it work.
Yeah, so maybe that's a lesson to learn for the future that perhaps teams of more than one advisor would be really useful.
Well, especially if you have different skill sets.
Yes.
Yes.
It
To
sounds
be
like
honest, Sydney
Hmm.
knows more Python than I do because I learned C and IDL. I was deep into IDL, and then I became a manager, and I didn't like code much anymore. So I
Oh yeah, I know how that goes.
so I like try to teach myself Python in the couple minutes I have every day.
well, if
But
you know, if programming is going to be a major part of these things, it probably, scientists would be a bad idea. You can tell that to the organizers.
you cut out a little bit. So you're saying that if
Oh,
programming was to be important, you need a
well,
scientist and
both of these use programming quite a bit, right? I don't know if that's true across the board, but it probably is, because how much can you do without writing some code? In which case, having a science input, helping define the problem, and some technical input helping guide the work wouldn't hurt.
So I would say that in Sydney's case, she really experienced how a scientist does this because whenever we just didn't know something, we just Googled Python, how do you do this? And put it into our notebook. So her code looks like a scientist's code, which is fine because that's what she was learning. There's a dichotomy between how scientists code and how engineers code. Engineers code for longevity and for other people to be able to use it, and scientists code to find the answer right now as fast as possible. So that's part of the culture that you guys both experience, and we made a lot of plots that we never showed because we were like, well, they're duds, not duds, but like they taught us something, but maybe not what we wanted to show. So there's a lot of exploration. We didn't have an endpoint that we were going towards. So yeah, but that's good. That's how we actually do it. So
Indeed, yes. There's a lot of sort of messing around and doing science and dead ends and doing things wrong and suddenly realizing you're actually asking the wrong questions and so on. It's not a smooth process by any stretch of the imagination.
exactly.
Well, of course,
It's a very
programmers
short time.
programmers get it right first time, huh?
Yes,
Yeah.
absolutely. That's the difference between technologists and scientists. Let me ask, if I may, a question for both Sydney and Pedro, and it's okay to be honest about this. What do you think didn't work very well about this virtual program? And are there things or suggestions you might make for improving it if we have to do it virtually again next year?
Oh God.
I would just say it was I want to say it was the communication, because sometimes an email it would take too long for somebody to reply to it. Like even for myself, I would take too long to see an email. So if like there were like some easier way to communicate that was like instant, that we could like see in the moment, like on our phones, that would probably be best for the future.
Like Slack.
Yeah.
Hmm.
Yeah, I think the hardest part is communication just because it's like not in person, so it's different. But other than that, it was pretty efficient.
Sydney, what are you thinking about for future career goals? I mean, not that you have to have it figured out or anything by any means, but Pedro mentioned that he was interested in engineering, and so I was wondering about you.
I'm not sure. I've been doing like App Academy and like coding all my life. And so I might go into something in like the STEM field, but I've also been looking at other stuff like psychology and stuff like that.
So the world is still wide open. Good. Well, I'm glad you got to have an experience which maybe helps you gain some clarity.
I hope next year this program is in person and not remote.
Yeah, it would have been cool if you guys could have come to bagels and donuts and talked to each other, and I would have learned that, people were meeting every day earlier.
Well, we do what we do. Well, I mean, I think it's a matter of just doing what we needed to do to make it work under circumstances that none of us really wanted to be in,
Yeah.
that we couldn't control.
Yeah. Well, I think that both of your presentations were very different, but both very good. So I was happy to see that there were success stories at IPAC for the SRC students. I think we're almost up. Well, we have 15 minutes on the hour, but we don't by any means have to complete the hour.
Pedro, could you send John and myself a copy of the final presentation? I didn't see the final one. I just saw the draft that we put together a little earlier on.
Okay, I'll do that.
Hey, thank you.
All right. Thank you, Sydney and Pedro.
Yeah, I'm glad that both of you were able to get a lot out of it. And even though we're working remotely, both of you persisted and both of you got a lot of work done.
And don't forget to put this on your resume and ask us for recommendations.
I'd be happy to do that.
We'll do. College applications open this fall, so
Yeah.
you can email me.
Now, if you need a recommendation, just send me an email.
Yep. All right, everybody. Have a good weekend. Enjoy Oregon and where you don't have the fires that we have right now.
Yeah, Pedro, stay up there for the moment. It's 100 degrees and the atmosphere is all smoky and stinky.
I'm actually kind of freezing up here. I don't know how much longer it can last.
It's going to be 104 today.
Okay, I'm fine here then.
All right. Bye, everybody.
All right. Bye.
Bye.
Bye.